Well, welcome back to our channel, Soaring Together. Rickey and I are here at our son and daughter-in-law's house. We've been here since we returned from the heavy-duty truck rally in Kansas, and just busy doing things, getting ready to hook up after Thanksgiving and head west for the winter. So in today's video, though, we want to take you back to the heavy-duty truck rally. This is going to be the second part of the presentation by Warren on the Multimeter. So we're going to go right to this, and we hope that this will help you in your RV travels.
These right here, again, when we're starting to talk watts, you know, this is how many watts does this have?
1440.
14.4 at how many volts?
120 volts.
At 120 volts, correct, on that part of it. This particular one is how many watts?
1650.
1650 at
120.
120 volts. So when we measure ohms, we want to have the electricity disconnected from them. Always have the electricity disconnected from them.
From that.
From this, correct. So if this is in your water heater on there, you know, you just connect you have one little pigtail that you can unconnect, you know, you can disconnect the other one, and then you put your probes on here and you'll be able to measure. So let's go to ohms. Ohms is ohms. Yep.
Is that 200?
Yep. So you can go
to money?
Yeah, you can go down to there, because all what it's going to show is a different decimal point on there. It just gives you and let's go ahead and let's put your probes on here and see if you have a good element or if it is bad. It's not continuity. You're measuring the ohms in it. It puts a small amount of electricity through that. And push on there hard. Dig it in there.
Had to leave.
What'd you come up with on yours, Rickey?
I finally had to turn mine down to 2 to
Two.
make it read.
2K.
Right. So your auto ranges, if it's too high, it won't. It clips the rest of those numbers off. That's why on yours you have to go down to what you think it might be. So in your case, if you don't want to do all the math and stuff, I would get one of the meters that auto range and does the math for you.
That's what I told him though. But if I'm reading up here,
You'll think it's right. You're going to replace it. You're going to replace the 7081 because you don't have it on the right.
Simply because I don't know how to read the meter.
That is correct.
Correct?
You're absolutely correct. Yes.
So
Warren's going to go out and buy us real nice
So buy one that
flukes.
autos and it'll take care of it. Is that what you're saying?
Okay. Now we're doing this on camera.
All right. Fuel sending unit.
Okay. Read the scenario.
Randy, the famous HDT trucker,
Well, I do know that halfway it quit working.
Yes.
suspects his sending unit is failing as he watches his fuel gauge read empty when he should have a half tank left. Or maybe one of the gremlins are sabotaging his wiring harness in his truck. What do you think? I think Randy should take it back to Volvo and have them fix it.
Okay.
Where'd Randy go?
So in this particular case, a new one, we tested the new one. Yes, it is a bad sending unit. We tested the new one, you know, and using your ohms at full, when this is rising up to full, it sends a reading, a value of 27. At 3/4, approximate right here, it sends a value of 65. Half at 99. But in his particular case, on his truck, it sent a value of 240, saying that this thing is empty. So when he had half a tank, his gauges on his truck was reading that this was empty, and so he pulls over to the side of the road and says, something's wrong, why am I sucking so much fuel? Well, when they manually tested it, you know, they still have a half a tank. So you can understand when these sending units start going out and they don't give you the proper readings to your instrumentation, it will make that very erratic. And he said that when he got to half a tank, it started sending either between full and then empty, and then it would just go ahead and stay around the empty side after that. Because your fuel will slosh and move this up around a little bit, but not tremendously like he was talking about on that. So when you measure that, you can go ahead and put your prongs in there, measuring on ohms, and we'll go up here and we'll just
Do I need to go up to 2,000 or should I stay down in the 200
Stay down in the 200 range.
200 range?
Yep. And let's try that.
You come over here on this side.
Oh, I'm fine.
First one.
26.8, 26.9.
So we're pretty close. Yep. So now let's move it down to 3/4.
You say it's supposed to be 65?
Yeah, around 65.
I'm
You're
at
getting
56.4.
56. Now let's go to half.
Okay.
So you go to 1, you're out there. So someplace in that area is where that thing seems to jump.
Right there. You still got it. And
72.
Here you don't.
And here it breaks on there. And so that was giving him, the computer system was measuring, well, it's way above the 240, so it read empty. Now if you go below it, you'll start picking it up again. You may. Nope, you don't on that one. Okay.
Do I need to? No, I should be below. Well, do I need to go up to the 2,000 then, maybe?
You can, but it's still reading. There's nothing below this point here on this
Oh, okay.
on this particular reading on there, so it's dead basically.
Okay.
Which I know.
Now sometimes if you take your lead probes off, you get better results on those.
I got weak in my old age.
Holy moly! How's
You
it?
squeeze and pull. Squeeze, turn and pull.
Oh yeah,
Yep.
I can turn it.
Well, I don't feel too bad now. I got one off.
There you go. Okay.
So you got a good loop there. Okay. All right. Now, with fuses, the things that you can test on fuses, if you've ever noticed that they have 2 points at the very top.
Yeah.
So if your electricity is off or whatever on your vehicle and you want to test because they're all in a row and they're really hard to get out, you can go ahead and test that fuse by putting one probe and one probe on there, or pull them out and test them via here if you cannot see through and see what,
I'll
if they're
pull it
fusing.
out and see if it's broken.
And see what's wrong. But, okay, so take a look. Is this one good or bad? How do you know? Because you can't see through it.
No. It's good.
That one's good? Okay. So what kind of fuse is that?
What, amp or what kind?
No, what kind of fuse is it? So if you line up, you got your maxi fuse, you got your ATO, your ATC fuses as such. So these usually run according to the amperage that they have in there. So this is a 5 amp, this would be your ATC fuse. This particular is your A&L fuse that you have over here. So this one is a 50 amp fuse and it runs over here into this category. And what it does, the size wiring chart tells you, it gives you
what fuse you need per.
Yep, for an example, as you go through these different things, it gives you a guideline as you go through it on that part of
Where
it.
can you get those charts?
There's a lot of them that are on the internet. Blue Sea has them. Just depends upon where you buy your fuses at. A lot of the manufacturers will produce or provide those types of charts that are out on their website. Now, I want you to go see if this light switch is good.
Go see.
Now I see that I don't think I've got the continuity on that thing, do I?
On continuity,
I didn't see it on there anyplace.
let's see.
That's why I was using yours. Throw it away.
Unbelievable, yeah.
What's up, Marcel?
You don't need power, you just try to determine if the switch works.
Oh, you just do the continuity on it?
Yeah.
Okay.
You don't have continuity on. That's remarkable.
No, it's not. It's just a cheap one.
Yes, I would recommend that you
Tell my wife that.
I would recommend you that you. I've heard that
Get
before.
a Fluke 325.
No, there's many other different kinds that are out there. What you really want to have is some type of, in the RV environment. If you're full time or if you like to do your own troubleshooting, a meter of some sort, a tester of some sort, especially with a clamp that runs AC and DC, Plus, you know, it has the voltage for AC/DC. It has your ohm reading. It has continuity. You know, it doesn't matter if you have your temperature. But amps is a critical element on there. So, and that is those are the mainstays that you utilize. That switch is good. Okay. All right. Now, this right here was taken out of a coach where we're talking about tightening down and making sure that your lugs are tightened to specs on it. They have inch
per pound?
inch pounds, and some
really?
different things have foot pounds depending upon what you're dealing with on here.
Like torque.
Torquing them down. This particular one was not torqued down. As they went through from one side to the other,
And it burnt.
it came off and it hit the side. When they plugged the coach in, it went ahead and recolored the box. And of course,
Made it look like a prettier color.
yes. So those are some of the things that when you're taking a look at, you know, maintenance is part of it, you know, to make sure that, you know, things are tight. You have to periodically go into the maintenance of these, and also in your breaker box. When you open up your breaker box, you'll see there's a little chart that's on there. It'll tell you how many inch pounds is such that you need to torque those tightens of those lugs up inside of that also, because they do come loose. And anything that becomes loose with electricity, you start creating heat. Heat is unwanted. It'll just escalate, and you'll start burning wires, and you know, causing some
And do they
failures.
make
So
such
do
a small
do
thing?
they make a smaller torque
Yes,
wrench
I've got a
for those?
torque wrench that goes on there, and it measures inch pound. Okay, what's next on our list here? What else we got to look at? Do you understand continuity? Okay.
Actually, I thought
Yes.
I did before, but so should this camera have continuity?
Well, take a look at it. That is actually off a rig that actually had some issues.
Well, it's smoked. I can see that.
It's smoked, exactly.
But theoretically,
Bad wiring.
You should have continuity.
No, it was actually good wiring on there. Something happened where it overcurrent the wire that you have in there, either for the camera or whatever. It melted right through. You can see it where it melted itself. And so evidently something happened. It touched the ground or on there, and then it melted the whole camera. It actually went out and destroyed both of the cameras. That's a dual motor system that they have for the Schwintek slides on there. It's a control unit that they have in there. And the application with this particular one, the customer, they have a reset button in there that you should use a BIC, like a plastic end cap, instead of something sharp. Well, they used something sharp and they busted the control unit by just pushing that in there, and they jammed it up. And so what ended up happening, we ended up having to replace that because it made the whole unit inoperable for that coach.
So a thermistor.
Thermistor uses ohms.
So when I pulled the whole harness
And they also have a chart for those things. So when you measure it, it'll tell you exactly
existing.
what
How
the
many ohms
dissimilar metals have, and it has a chart that goes to for those particular temperatures on there. And so you have to go to the manufacturer of what they have, but you measure it in ohms, and you can go ahead and put it on there, and I'll show you.
But I'm in continuity and ohms.
Yes,
Okay.
it does it.
but it was all taped. So all of that arcing and heat.
So what do you have? 10.2. Now I'm going to put my hand over it, and I'll watch what happens.
What we're doing now? Still checking continuity.
See how it starts moving?
Yeah, going down now.
Right. So the heat of my hand for
Heat of
this
your hand is making it the continuity.
It's changing it.
Changing the
So the
continuity of it.
the computer that they have with these things in the refrigerators will read when it hits a certain level, it'll release and it'll call for heat, on
Which
that
makes-
part of it.
Yeah,
which
keeps it cool then.
correct. Yes.
Right.
Yeah. And so each
I can do
manufacturer,
that part. I got that.
each manufacturer that they have has a different. They have different chart ratings for their
okay.
product that they have on it. But that's how you can test it. So if you're wondering if you're in your absorption refrigerator why you're having issues, for instance, on there, and you suspect that it is a thermistor, it's a thermometer and a resistor put together.
Right.
That's one of the options that you have, is using your multimeter, your multi-testing tool, and going ahead and testing it through the ohm.
Or if
functions.
they had taken it out and put it back on the wrong fins,
Yes,
left, right, up, or down.
yes, and that changes because of the temperature that's inside your box.
Right.
Yep.
Gotcha.
Okay. So we went through, we did capacitance, diodes. Diodes is another area that we have, and on your...
I've done diodes.
You done your diodes?
I don't know that he has.
That's all right. Go ahead.
Your diodes are over here.
Yeah, I'm just
Okay.
hanging along with Mitch.
Okay, so if you've done your diodes on there, basically what they are is a electronic one-way valve,
One-way
to be
valve.
very simplistic about it. And some of them will block electricity. They're used quite extensively in your solar panels as such. And that way when the solar panels, taking on energy, it's pushing the energy, it's going through your control box. Well, these diodes prevent the backflow of energy coming back in when the sun goes down as such on there. The other element that we have tied in with that is continuity, because with the solar panels you have a fuse on some of the lines in there, and you can test and see if your fuse is making it through. You may notice that
That's a fuse?
that is a fuse in there. So go ahead and let's test this for continuity on there. And how they test it, they can come apart and it's a little fuse that goes inside of it. But
So
you just,
both of them down here?
you can plug in both ends, correct, yeah? On this one, on this end
Oh,
here.
this end.
So
That
that
one's
fuse
good.
good?
Yep.
So that fuse is good on that. If you didn't have continuity in there, you'd know that your fuse is bad in there. You can use your tools to open them up, replace the fuse, put it back together.
Oh, so
But
there's a fuse inside
there's
here.
a fuse inside of there, correct?
I see.
Yes. And then you want to check upstream of it and see if there's any damage of what might have caused that breakage, or downstream, at the combiner box, to see if there's
Now, is
any-
that one of those round fuses? The long glass fuses? Or is that a...
Some of them
Is
are
it a
glass.
mini?
Yes, on there, and then they differ. I'd
Okay.
have to open this one
That's
up again
fine.
to,
I didn't
to
know
figure
what-
out which one they had
What type
inside
of a fuse
it.
they use in those things?
Yep. Okay, we're going to go into. Let's go over to the extra credit table. Let's go over here. This is your extra credit table. Okay.
done.
So here you can go ahead and read the scenario.
These are heating elements from a Norcold 2118 absorption model refrigerator. Uses AC, DC, or DC propane to operate. On each heating element, you can see they are stamped with 300 watt at 120 AC, alternating current.
Yes. I do know AC and DC. That I am pretty
What is the OHM reading of each heating element? Well, first thing I need to do,
And
what were they?
the content.
3,000 watt.
I haven't done that in a while. Where are you trying to get to?
I'm going to check each one of these.
Okay. And how many?
So what are you moving your multimeter to, or your tester to?
Yes.
I'm moving it to the
AC.
ohms,
To the ohms. Okay.
right?
Yeah.
Okay. Well, is it supposed to stay?
Try mine.
Here we go with the.
You can see where, when you get your test instruments, there is a.
Holy moly.
Obviously, they're right. Yes.
It almost needs to be the little,
Do you want the small probes?
you
for
need
it?
the small probes
All
for
right.
this.
Let me grab them.
Go ahead and try it.
Okay, these are needle probes. Be very careful so you don't pull yourself out with them.
Is there a,
You just stick them in there. Just line up the hole and push them on.
okay.
And please be careful with it because they are extremely sharp.
I think like today was so much better because it was targeted people. I like it better.
That one's good.
Okay. How many ohms are you getting off of them? Are you touching both your leads together by chance?
I don't think so. No?
Okay, so how many ohms you pull in there?
Well, I don't know. 0.1?
0.1? Okay. Let's test the other one then.
Is I right?
So go from one to the other. Because
Do
you're
what?
just testing one leg of the plug on here. You should go from this one to this one. Because it has to go
I'm
through.
sorry.
It has to go through. Now what do you have?
45.5.
45.5, okay. All right. And so on this particular, they have stamped in the metal, and you got to get it in the light to see it. See that markings right there?
Yeah.
That's the readings of what this is supposed to be for a fully functional. And what is that reading?
Well, I think it says 65. Am I right there?
Don't ask me.
300 watt.
Those who don't care about advanced stuff can leave.
It's a 300 watt.
I only see 2 zeros after the 3.
Okay, so we got watts and we measured it with ohms. How do we get from watts to ohms to see if we're close?
120 volt. How do we measure from watts to ohms?
Well, how do we figure out if we're close? Because we know on here you measured it with ohms,
Right.
and that is telling you that it's for what? How many watts?
Well, it says 300, I see.
300. Okay, so
I thought it
remember
was
the
supposed to be
formula?
3,000.
What's the formula?
Oh, 300 watt.
So what law do you have to use to?
Physics.
Oh, physics. Let's try Watt's law.
Watts times,
Watt's law.
What was it? 4 point?
well,
Was it?
watts equals
45.5?
volts times amps.
Okay. So you know, what do you know? You know it's 120.
I know it's 120.
And you know you had how many amps or ohms, excuse me?
45.
45 point something.
45. Okay, on that. So I'm sorry, you got to use Ohm's law, excuse me, on there, because you got, you know your volts, you know your amperage, and you know your resistance. So right here we know voltage. We're using Ohm's law, so you know your volts, you know your resistance, and that will tell you what your amperage is on there. So you take 125, and you got what for a reading on it?
45.5.
45.5 on there?
Somewhere around there.
Okay, so we know that the ohms are 45.5, so if you take 45.5 and you divide that by 120, you come up with what? About 2.5 amps, right?
Is it? Okay.
So then 2.5 amps, moving it back over to Watt's law, because VI, so 2.5 times 120, how many watts are you running then?
It looks like 300.
300. So is that still good?
To me, that's still good.
Okay, so that one's still good. Test the other one.
And so do I need to do each one of these separately then?
Yes, because it runs through as a circuit. One wire comes through here,
Okay,
and it
you
comes
grab
back
the other
there.
one.
And now what you're going to notice is with your meter, if you have it off, it doesn't read very well.
Yep, that's true. Well, I shut it off because you told us to be shutting those things off.
You busy?
It's got
46.5.
So that's got to be good.
46.5?
Yeah.
Okay, so are both of those good then yet? Okay.
Well, we got to look at this and make sure.
Now, take a look at that.
But this is,
Would you want that back in?
no. It's starting to,
That's what I remember.
Well, take a look, do the math on there. So if you take a look and you do your calculation, so you know you had 120 volts,
Right.
and you had to divide that by 2.5 amps, you should come up with 48 ohms. is the
Max.
is a good rod based on 300
Watt.
based on a 300 watt requirement for it. That's the standard. So when you did it, you should have come up with 48. You
We
came up with
45.5.
45. So that was less. So are these things waning from its standard?
Are they doing what?
It's waning from its standard. It's
Yes.
going less than it's from its
Yes.
standard.
Yes.
Right. So you're waning from it. Plus, you're starting to see some damage and wear on it. So what you would do is say, it's just cheaper to go ahead and put 2 new ones in there, get back to standard, and let that thing, operate as it should.
So is it good to check your new one before you put it in?
Yes, I would always check your new ones on there before you go in, just to make sure whatever is indicated, stamped on there, is good. The diodes that we have out here that we utilized, you notice one worked and one did not work?
Yes.
Those are brand new out of the package. Brand new, shipped to me. Some of them worked, some of them did not work. I had to check each one of them. Okay, so that right there,
So, but this would be on that.
Just the wattage.
this is just the wattage.
Right, so
So this-
300, so that's how we get this number.
That's how you get that. You
That's how
take
it's
300
made.
watts divided by
By
1 point, you
gives
should
you
be seeing
2.5
2.5 amps.
So when you take that,
When you move
then
it to Ohm's law, because you're in
decides-
Watt's law,
right,
now you move to Ohm's, it's 120 divided by 2.5,
which should be 48.
should be 48, but you measured what?
45.5, 46.5.
Yes, so that's lower than that. So you're waning away from the standard of what that element was
Okay.
designed for.
So is there a limitation?
There is a limitation with plus or minus, a little bit on there. But when you start seeing damages such like that, it's just better to go ahead and move on to something new on it. Some of them have them stamped on there. I'm not sure all of them do. They don't on that part of it. But that's just, that's a call as you walk through on there. Okay,
That's a call for a technician.
that's called for a technician. But if you're doing it yourself, they're not hard because you're just, most of your absorption refrigerators are becoming, a thing of the past on a lot of the rigs.
We don't have it.
A lot of the 12-volt systems are becoming more prevalent as already the residential systems on that.
Best thing they've done.
This right here, this board is one that you could play all day long and figure out what you're doing right and what you're doing wrong with it. Because you got the opportunity here. You got the opportunity here to.
So is that what you just broke?
No, I stepped on one of the other connectors down there. So, like, if you want to see your courtesy lights, that's what you were wiring into, right?
I don't know. Where are you going?
Marker lights and such. So you can play with these and actually wire up. We've got some little ports you can wire up some of our other lights and watch what happens on it. Then you got your hazards to see how they work in there, and you can follow the wiring diagrams and the thought. You got your turn signals. You got a brake that comes up, and then this will be one of the scenarios because when you hit, if you have disc or drum brakes, when you change and you re-grease your bearings and that's a great time to take a look and see if your connections to your brakes are also working. And again, when we talk about amperage, you can hook up your vehicle and have someone hit the brakes and you'll be able to measure the amperage to see if those things are working back there or not. Or if you got a break in one of the wires, and we'll walk through that part of it.
Mine's all this.
Your disc brakes. Yours
I'm disc
runs a
brake
bit-
too.
Yeah, and yours is hydraulic versus electric. This is for
It's
the.
electric. It's electric over hydraulic.
It's electric over hydraulic for your particular one.
Yours
Right.
is air over hydraulic.
Mine's air over hydraulics. So that your electric system terminates basically at the box that goes to the controller unit. Some other folks that have trailers out here, they have electricity that runs all the way back to their brake drums on there that work some of those
For the drum.
for the
For
drums
the drums
because
to
they're
open
magnetic.
and close.
This.
Yes, on that. So that's what this is kind of set up, because in our arena here that we have in this forum, we have those that have, their basic level trailers, and then we have some of those are very, very sophisticated, trailers. So there are differences in it. But this just gives you a basic knowledge, to try troubleshoot and take a look at some of those things and play around with it. So on this particular one, what we can talk about is, like, if your brakes as such come on, your cabling that you have hooked up, a majority of the problems that you run into is the ground. You know, if you got lights on, if you got courtesy lights on, and you've got a bad ground, see how it starts going dim or intermittent? And I'm just using this as an example. This could also be one of your wires that are attached to the frame of that vehicle. You will, you know, as that thing's bouncing up and down, see how, you know, it gets really dim and such on there, and they go out. You know, you might have one that is in there. Some of those times it's because of a grounding issue.
Well, here again, is it okay to go ahead and put the dielectric grease on it to, isn't that supposed to help the connection?
It does, but step one is make sure you got a good clean surface on that. Step two is make sure that, you know, your connections are solid that you have on there. And if you can at all, with a lot of your electrical, if you can waterproof them, this is an example, you know, we're using, you know, these types of connections, but in reality, you should actually have them heat shrunk, you know, and sealed together. That way you don't have that moisture getting in there and destroying those connections as such on there. This is just for an example, because you can plug in other wires into this thing, you know, and test to see if you got, you know, see if they work. So I'm putting in on this particular one. Now, why isn't the light coming on?
Because you're not grounded.
I'm not grounded. Okay, so now if I ground it,
Still doesn't work.
I'm still not getting anything on here.
I thought the
So why am
white
I not
was
getting
the
on?
ground.
Huh?
I thought the white was the ground.
That's a great transition. So take a look right here at the styles that you have on here. You've got a 7-way plug trailer side, and you've got a 7-way plug RV blade style. The differences about these things is, notice the locations are a little bit different depending upon if you have a plug or if you have a blade on that element. But if you also notice, even between the blade styles, you have an auto industry and you have an RV standard. Exactly the same plug, but you notice the colors are different wiring styles as it comes on. If you notice white, okay, that should be common. Blue should go to your trailer brakes, got it. But oh, now we went from a yellow to a red. What's that all about? And we got a green that goes to a brown and a purple that goes to a yellow and a black looks like it's disconnected for accessories on there. But then we got this brown that's going to a green on there. So they're, even though they are all different colors, if you notice the same location where they wire into the pin are the same. Why do they do a different color? I don't know.
Is there, I mean, really, is that an answer? I don't know.
Well, they have their own standards is what they basically have come up with. Why they chose different colors for the RV industry versus the other one, I don't know the methodology behind that part of it. But let's turn on this. So we've got a green. So will we be able to get anything at all? This light just is not working on here. So we're going to take a look on here. We should have something on here, you'd think. See, we're still not getting anything at all for the grounding on that part of it. Why is that?
You're the instructor.
Well, you've lost the connection somewhere.
I've lost a connection someplace
Or
on
the
there.
light's bad.
The light could be bad, possibly. Yeah. There's no brakes on that. Oh.
Test the light.
Can we test the light? Yes, we can test light. So how would we test the light?
Continuity.
We take it to a known source, right directly to a known source on the battery and see if we got connectivity on here.
That's what Paul told me to do to see if my
On there?
light got.
So is that light coming on?
No, it's
Nope.
good. It's shot.
No.
So
So,
you've been over 30 minutes with a bad light.
huh? Yep. So you already got a bad light when it comes on. That was a brand new light, you know, when it came in.
Somebody probably stepped on it.
So it's, you know, so you got to test them, you know, too, that you have in there that to make sure that there's something that hasn't gone wrong with
Tested
them.
none of my new ones.
Pardon?
I never tested any of my new ones, but Paul told
Oh,
me.
there we
Look
go.
at that. What happened here?
He had a bad connection in there someplace.
Did we? Okay, let's turn that around again.
No, it's
I'm getting a
positive-
bad. I'm
no,
getting a
it's
bad light. Why is that?
No, because it's the positive in the ground.
Okay, exactly. So when you wire up your lights sometimes, and you know that they're going ahead and they're not getting done. So if we go ahead and we switch this around, so we take this one, we had it like this, correct? Did it light up? Let's give ourselves some power here. And we'll go touch our ground. It's not working.
What are you grounded to?
You got
I got rounding strap and back.
Okay.
So now if I go ahead and I switch the wires around.
so they've got the. Do they have the ground backwards on the light?
No, no. I'm just showing a point here.
I'm trying to figure out what his point is.
The point is there's
that
a,
part I think I do know.
there's a certain way to wire these things up, you know, on there when it comes through there for your electricity. It's got to come through, you know, your LED a certain way. Because if you reversed your wires and you wired it up the other way, you'll never have this light up. Understand? So if somebody goes ahead and puts the ground
On it. But see, that's what I done with mine.
and they put it on there and they say it's gonna work, it's not working.
Only on my.
Do you understand? It's got a one. Think of it as a one-way
Isn't your
valve.
black your ground?
White needs to go to
The power.
power. Now, once we do that, we have light. Understand that?
Okay.
Part of it? Okay. Now, when he's talking about he's wiring one of these things into, you know, for instance, a turn signal that he has on there. So if we follow our pattern around and then we can find one of our outlets here that, you know, so this one right here comes in and our black wire comes out. So we're looking for the orange. Is there any other extra orange that we made so we can plug in additional? Can we get any down here?
So you hook the black to the hot.
Okay.
What's green?
Okay, so where's my
That's the terminology I use.
Yep, yep. So if we go find another ground here, this is a ground here. Now, that one turned into a turn signal on there because of the relay that it has inside of here. So now if I turn it off and I turn on just my regular courtesy lights, it won't come on. If I hit my brake lights, it will come on because of the way the relay works inside of there.
Correct me if I'm wrong here. To be a marker and a turn, it has to be 3 wires.
3 wires, yes. Now, can you fool it? Yes. Yes, you can.
Well, that's what I've done. I had it
But you need, they utilize these types. This would be like from a 3-wire to a 2-wire converter, you know, that they have. But that's a whole different ball game that you come up with on it. But yes, for what you're talking about, and I wish I had my three wires around here, because you're exactly, that's how you'd wire it. And then you'd have your turn markers, your mid markers and such on there. So when you go back in.
I know you understand what I done.
Yeah.
I tied the high to my marker, which made it brighter. I turned to the low.
Yeah.
But it was supposed to be the opposite.
We're going to move to another scenario here. We're going to take this scenario that we have here and we're going to tie it to this one right here.
The old brake.
All right, so go ahead and read the scenario. What's your scenario say over there?
The trailer undercarriage system during your annual bearing repack and seal replacement, one of the electronic drum brakes is suspect of no longer working. Find out why they are not working.
Because you don't have a wire hook to it.
Did it hold the screwdriver on when power was supplied to the brake drum?
Okay. Okay.
So you ready?
So if you press the brake,
It's not working. Why isn't it holding?
Because you got something wrong.
What could it be?
Electrical.
Possibly. What else could it be?
Your bad magnet.
Possibly. Come on, start doing your troubleshooting. I want my brakes fixed.
That's about as far as you're going to get with me.
Okay, go ahead and push my brake again. Oh, it worked.
Stainless steel.
Exactly, stainless steel.
Yeah.
So if you have any stainless steel that you're trying to go ahead and see if it works, it ain't, you're going to get disappointed in your reaction on it.
That's why you said screwdriver, because screwdriver ain't stainless steel.
Yes. See how that holds it? Okay, so if you have a break in it, now the other way that you can test it, if you grab my amp and you got your truck hooked up, you know, and you're sitting there and you're not feeling brakes.
Applying the brakes inside.
What would I utilize here to figure out if we're getting current through here?
Ohms.
You could use ohms.
No.
Continuity.
Could be another thing, but what is a quick fix? Yes, amps. Exactly. So if I clip this on here and I have, okay, hit the brake. Ooh, I did. Oh, it's intermittent. What does that mean?
Still got a bad connection.
I've got a bad connection someplace, so that's where you start. And for me, it's right here.
Because you didn't torque it down far enough, Warren.
You apply the proper torque.
Okay, so there we go. So go ahead and release. Okay, turn it on again. Did you notice how it finally quits off?
Yeah, it's locked, yeah.
Because it's used up. You know, that magnet, it's at its max, it's pushing those things out, and then it goes ahead. So you'll go ahead and hit it again. See, you'll hold it, now let off. And it drops on there. Now just hold on to it.
And eventually it'll lose its power and drop.
Yeah. I thought it would.
Well, it's got applied power to it. It's got something that it's using up some of that. Now it should end up dropping off eventually. The magnet's energized. It's holding that thing good. Now let off. And it goes off. So when you're checking them, if you ever do your bearing and you come up to a drums assembly or such like that, make sure you check all of them in there. And you might hear the things click too, because they'll usually be really dirty or whatever on that, and you'll hear those. But if if it can't hold a screwdriver, start looking and checking the connections and such on there. It might be just one wire. These in the field, these are not what you want. You want to have these things butt connected with your heat shrink around there, because they take on so much debris as it comes through. They get beat up quite a bit if you ever look at a trailer that has these things in here on that. And then they usually go through all your different wheels. Yeah. These, I would never use these in the environment on there, but yes.
I'm writing things down that I need to buy, or the wife needs to buy. Hi, Jane.
Okay, going back to your wet cells. If you have wet cells, you check them monthly. And what do you fill them with?
Distilled water.
Okay.
She even knows that.
All right. There's a lot of folks. Also, when you're in there, always check terminals. But the more important one, like even on your trucks, is that ground.
Right.
Make sure you clean those things up. And it may take you an hour to clean all the bars if they're all tied in. What is your trucks tied in usually? Parallel or series? Parallel. So they got those bars that'll go across on it. Take those things off, shine them up with a sandpaper, or some people, whatever it is, just to clean those contacts off. On there. Clean the contacts on these. Reset them. You can put some dialect grease on there. There's also spray that the folks put on it, so anti-corrosion that you can get on there. But make sure those points, because that will throw a lot of your codes in your trucks or in your trailers. It will give you a nightmare, that intermittent that you'll start chasing, and it'll take you quite a long time on that part of it. But yeah, if you have any of these batteries that are still requiring maintenance, always check them for that on that part of it.
That's a good subject.
Thank you, Warren.
Not a problem. I appreciate it. It's been fun. It's been very educational.
Well, Warren just did an excellent presentation, and we want to thank him for allowing us to video. And we just want to thank you for joining us and following us along on our journey. We're getting everything ready and going to be heading west after Thanksgiving. We'll be out west for the winter. So we want you to follow us along as Rickey and I are soaring together and living life in different places. Thanks for watching.